This is Josh White with JW Math Tutoring. In today's video, I'm going to take a look at 13 problems from the March 2026 Digital SAT Math Exam. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Welcome to March 2026 SAT official test problem set and video number 1. So this is the first video for March 2026 official exam self-reported problems. There's also a couple school day problems mixed in here as well, but most of these are from the Saturday, March 14th exam. So a couple things just to mention before I get started. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, make sure you check out video number 2, which will have 13 additional new problems, and then also video number 3, which will have 16 basically repeat problems that I've covered in the past on at least one or more videos. So I don't go through those problems in detail. Basically, I just highlight them and then show you, a copy of the problem and exactly which video or videos it was previously featured in. Third, there'll be a link in both the description of the video and in the pinned comment to download the PDF file for these problems that you see on the screen. And I think, as always, any questions or comments or alternate solution methods, feel free to leave them below. And then lastly, I've tried to recreate or sort of reverse engineer these problems as best I can, based on the information that people posted. So there might be some slight variations. You might see problems that are different. They're slightly different than one you received on an official test. And that's fine, but I've tried to make them, I believe, as accurate and as workable as possible. So just keep that in mind, because I do not have a copy, of a March 2026 test in front of me, as I'm writing these up. So with all that being said, let's go ahead and get started here on question number 1. Now, this is technically a repeat problem, and if you have watched the videos on my official test, problem set playlist, and you went all the way back to June 2024, you would have come across this problem. And therefore, you would have known that the answer to this is letter D. Because this exact problem was featured on that exam, self-reported on that exam, and therefore I highlighted it in the video. Now, it's slightly different in the video. I think it was triangle ABC. Here it's JKL. But everything else is pretty much the same. I think also the constant values might have been slightly different in the video. Like the J here is 90B. That part's the same. But the K and L could be any two numbers that add up to 90. So in this example, it was 53 and 37. I think it was different numbers back in the June video, but you still solve it, using the exact same method. Okay, so just to talk about this one a little bit, I won't go in this one in too much detail, but the whole idea is A and B, are constants, but they are not necessarily integers. So A and B can be any number such that basically, when you plug them in, you get 180 degrees for the measures of the three angles. Okay, in other words, that they make a triangle. So, most people, and I'm just going to type this all out just for demonstration purposes. So it'll just be easier to update the values, and then you can see exactly what happens to the angle measures, and we can also see what happens to the sum of the triangle measures, just to confirm, everything is 180 degrees. Okay, we're comparing cosine K, and we're comparing, get rid of this, sine L. Now, we do want to make sure we are in degree mode. Okay. All right, so Most obvious thing that people think is, okay, well, A is 1 and B is 1, which means that angle J is a right angle, and then the other two angles are 57 degrees, 53 degrees, 37 degrees. So see here the total is 180. That checks. Therefore, the cosine of K is equal to the sine of L. Cosine of an angle is equal to the sine of 90 minus that angle, and vice versa. Okay, so a lot of people thought the correct answer was B. However, this is not the only possibility. Let's say instead I make A equal to 0.5 and I make B equal to 1.5. All right, now first let's check our angle measures. Okay, they're all listed up here: 135, 26.5, 18.5. All right, do they add up to 180? The answer is yes. So therefore, these are acceptable values because they still make a triangle. Now, what happens to cosine K versus sine L? That's what we're comparing. Well, we can clearly see here that cosine K is greater than sine L. Therefore, just based on what I've done so far, essentially that we can now conclude it's going to be D. Okay? We found one example where they're equal. We found one example where one is greater than the other. Therefore, it's going to be D, not enough information to determine. You cannot conclusively determine that one of these statements in A through C, is always 100% of the time true. And lastly, just to show you, and you wouldn't need to do this on the test, but just to show you, say I make A 1.5 and B 0.5. Notice it now changes the measures of the angles. However, they still add up to 180. And now sine L is greater than cosine K, or in answer choice A, it's technically cosine K less than sine L. So you can find values for A and B which will meet all three cases. Therefore, the correct answer is D. It's not enough information. Now, if it told you that A and B are integer constants, then yes, the only possibilities would be A equals 1 and B equals 1, and therefore they'd be equal. But I do not believe that is the problem that was given or written or intended. Okay, so just be aware of that. I believe the way the problem is written is A and B are not specified as integers; they're just any constants. Therefore, correct answer is D. All right, next question. This one was actually reported from a school day test in March. So let's take a look at this one. We have a rhombus. Let's see how I drew the picture here. I think I put Q, R, S, T. Okay, and then we have the two diagonals going through the middle here. Note in a rhombus, the two diagonals are perpendicular. And this is point P. The ratio of QP to RP is 20 to 21. So that means this is like 20x and this is 21x. They're not necessarily 20 and 21, but they're, if you took the two overall values and divided them, you would get 20 and 21, which means there's some common number. I'm just using this x here, a common factor that they're each multiplied by. All right, perimeter of the rhombus is 464. So here is how we attack this one. We take 464 and we divide it by 4 because every side in a rhombus has the same length. That means this side is 116. I mean, just like all the others, you don't need to label this, obviously, if you're doing this problem, but this is what it's going to look like. All right, so now we know that 20x squared plus 21x squared is equal to, I should write equal before I'll use the tilde for regression, the hypotenuse squared, which is 116 squared. So basically, I'm just looking at this right triangle using Pythagorean theorem, and that's going to allow me to solve for x. Once I know x, I can determine the length of each of these legs of the right triangle. That can get me the full length of the diagonal, and then I can just add them together. And I can actually do pretty much all that in Desmos. So, solving Pythagorean theorem using regression. I'm just going to type this as a regression statement. I want to square the whole thing. There we go. 116 squared. All right, so it turns out that x is equal to 4, which means this side is 80 and this side is 84. Now, properties of a rhombus, or technically any parallelogram, the diagonals bisect each other. So this is 80, this is 80. This is 84, down here is also 84. All right, so QS, 80 plus 80, 160. RT, 84 plus 84, 168. Add them together, total final answer should be 328. That is the answer based on these, given values that you would fill in. All right, let's move now to the problem at the bottom of the page. This is actually basically a repeat or a carbon copy of a Blue Book test question. I forget the specific test that it's from, to be honest with you. It's one of the earlier ones. It's one of the ones for 4 through 6. But basically what's going on here is you have a circle. Okay, you have the center of the circle, which in this case is point B. Then you also have two points on the circle. Okay, point A is going to be up here, and then point C is going to be down here. I'll talk about how we know where they are in a little bit. So A has these coordinates. Notice the center here is like they just give it as h comma m or whatever letters they give you. So A is at h plus 1 comma m plus root 112. That means to get to point A, you go to the right one, and then you go up square root of 112. So think about like moving according to the slope of a line. You go right one, up root 112, and then if I draw the line segment connecting them right here, this is actually going to be the radius of the circle. Then, if I draw another line segment over here, ignore the fact that it does not appear to be the same length, this is also a radius, connecting B, the center, to C, a point on the circle, and more importantly, this triangle is a right triangle. Okay, so that means that right here, this is a right angle. I can connect this, and then we can find AC once we find the value of the radius. So, looking at the small right triangle first, here, here, here. Again, we will go back to Desmos. 1 squared plus root 112 squared tilde r squared. Although actually, based on the format that the answers are in, let's make this equal for right now. The radius actually comes out to root 113. I'll show how to do it in Desmos just in a second instead of doing it by hand. So that means this is root 113. That means this is root 113. Now this is an isosceles right triangle because both the legs are radii of the circle. So the shortcut formula would be, well, just take the leg, multiply it by root 2, and then that's your answer. So you have root 113 times root 2, which is just going to be root 226, and that's the correct answer. It's letter C. However, if you didn't know that, you could just go to Desmos and you could do root 113 squared plus root 113 squared equals C squared, and you could get it that way. Now, just to show you, so for the first calculation, again, you would have 1 squared plus root 112 squared tilde r squared. Okay, so there's r. That's basically the square root of 113. Now, what you're going to do, and this is kind of the tricky part, basically you're going to take r squared plus r squared, and that's going to equal c squared. But the problem is you can't carry something over from multiple regressions. So if you wanted to carry the value over, what you would do is you would do r squared plus r squared, and then that's equal to, you wouldn't do c squared, technically you would do x squared, and that will solve this for this x right here is your hypotenuse. You know, that's the value for AC. And you can see the number is right here, 15.033. So now what you would have to do is you would have to go through and you would type the answer choices. Okay, A is obviously out. B does not match it. Okay, this one looks pretty close, 15.0333. So this is going to be the correct answer because obviously just 226 on its own is wrong. So that's how you could do it basically in Desmos. You just have to match up the decimals. Or again, an alternate way would be you would just have to type this. Basically, and this is, again, a lot more work, a lot more time spent typing. Again, notice here, if you just manually type it out, you still get very, very similar answers if you solve the equation. But you would still have to go through the answers and type them out and see which expression is equal to this decimal value. So that's how, if you wanted to do all the calculations in Desmos, what you would have to do. All right, let's look next. Question number 4, top of the next page, some similar trapezoids. So we have seen questions like this before, but I did just want to cover this one because it deals with a trapezoid. Usually it's with a parallelogram or a rectangle. But this one, okay, so you have two trapezoids. One of them is larger than the other, and it's technically EFGH, which is the larger one. You do not need to draw this out, by the way. I'm just doing this to help visually. So the area of the small is 450. Area of the big, 1800. Length of AB, 50. What's the length of EF here? We'll call it X. The whole idea, the whole concept behind this is that you find what I call the area factor, which is basically like what do you multiply the area by to get from small to big. The way you find that is just divide 1800 by 450. Okay, the area factor for this is just going to come out to 4. That means the scale factor is going to be equal to the square root of 4 because the scale factor is the square root of the area factor. Therefore, the scale factor between individual sides is just equal to 2. What that means is, like here, you multiply the area times 4 to go small to big. Therefore, you multiply each individual side times 2 because it's one-dimensional. Area is two-dimensional. So one-dimensional, 50 times 2, the answer is just 100. And that's it. Nothing more to do for this problem. All right, let's look at the next one, which talks about the concept of standard deviation. So these are basically like supposed to represent various data sets with 5 elements. And it wants to know which one has the smallest standard deviation. If you know about the theory of standard deviation, what it's measuring, which is how far apart the data is spread out from the mean, you can just look at this and you can tell, well, the correct answer is going to be C because these are all the same. Basically, the standard deviation for this would be 0 because every single value is the same number, which is the mean and also the median and technically the mode as well. However, if you weren't sure about that, what you could do is you could go to Desmos and you could use the standard deviation function, STDEV, and you want the P at the end because that is standard deviation of a population. You do not want just this right here. That's standard deviation of a sample. Okay, so you could type P minus 10, P minus 5, P plus 5, P plus 10. Then just make P whatever positive number you want. Let's say I'm going to make it 2. Okay? Notice I get the standard deviation here, 7.07. Notice when I move the slider, the standard deviation does not change, right? It stays fixed because it's the relative spread between the numbers isn't changing even as the numbers themselves are by increasing or decreasing P. Okay, so this one is 7.07. Let's check the next one. It looks like, by the way, the next one I technically, for me, it looks like I only typed 4 values. It's supposed to be 5 values, so I'll correct that on the worksheet. So for what's typed, it's basically this. It's really supposed to be okay, it's really supposed to be this. It's supposed to be 3.162, but for what I've typed there, it's a little bit higher. But the point is, it's smaller than A, but when you check C now. See, it's 0. That's going to be the answer. And, I mean, you can double check the last one. 3.39, whatever. Okay, so correct answer for this one, again, it's just going to be letter C. This is how you could verify or check this in Desmos. All right, let's look at this next one now. This one is actually a tricky one that I had to spend some time on figuring out. I actually found 2 different methods that you could use basically to solve this. So I'm going to show you both methods. You can determine, which one you prefer, which one you find easier to do. Okay, method 1. I am going to Desmos. I am going to graph both lines. All right, I am going to add a slider for C. Value itself doesn't matter initially. Okay, now what I'm going to do is see, is it basically based on this value of C I pick, is it possible, which of these answer choices is possible? All right, so for example, let me just start off with 10. Okay, say let C equal 10. So if I let C equal 10, C, the solution for C would be the point 10 comma, actually I'll just type it this way, 10 comma 0.33. Okay, is that the solution to the system of equations? No, it's not. It's way over here. Okay, so C is out right off the bat. And then D, which is C comma 0, I mean, that's very, very close to it. Let's turn this one off. Turn this off. Okay, that's also not a solution. So those 2 we can just go ahead and get rid of right off the bat. They're wrong. All right, so we got basically 2 of them left to check. Okay, we got 1 positive 10, 1 negative 10. So what I'm going to have to do here is basically increase this. Basically, I can increase the value of C to large enough that I can slide it over to where my X value is right around positive 10. So like, looks like right here maybe, right? Okay, so let's see what's the solution. It's pretty close to negative 10. Excuse me, it's pretty close to positive 10 for the X. It's not quite at it. And then if you look at the Y value, okay, negative 0.30275, it's very close to negative 0.30303030. So this one looks like it could be the correct answer, but let's check the negative 10 just to make sure. So as I move this over, whoops, went too far. Okay, so right over here looks like it's at, not quite, there. Looks like it's right on negative 10 for the X. Okay, so here's my solution now. Is this Y coordinate 330? No, obviously not. It's 0.30 something. Okay, so this one's clearly wrong, so correct answer is going to be letter A. So this is the first method. This is how I initially attempted to solve this when I first came across this problem. Now I want to show you a different method though. So what I'm going to do next I'm going to go through the answer choices. I'm going to plug in the X value of each answer choice, the X coordinate, and I'm going to plug in the Y thing. And what I'm going to look for is, all right, why is it not giving me, oh, this is Y1. There we go. Okay, this is the left side of the top equation. This is the left side of the bottom. They're both equal to C. So if the values I choose for X and Y, X1 and Y1, when I plug them in, I'm looking for the answer choice, the solution, is going to give me the same value for both of them, meaning that they're equal. I.e., I get the same value for C. So notice that's what happens on this one. Now, let me just get rid of this. Okay, so now let's try, and I'll just show you if I do this. Notice here we do not get the same value. We actually get opposite values, but the point is they're not the same, therefore it's not a solution. Okay, so this eliminates B. Now for this one, okay, you got to, again, pick a number for C. So notice here, again, they're not equal. And you can keep moving the slider, but they are basically never going to be equal no matter what number I pick for C. Notice I move the slider, they're just basically not equal. And then same thing if I move this over here. Again, notice they are never going to be equal to each other. Okay? So this is a second method. That's an alternate approach or method that I found. I did not find any quick or simple or easy way to do it algebraically. If you have a suggestion or idea, feel free to share it. But those two Desmos methods were basically the fastest and easiest ways that I found to work this one out. Okay, next question. This one dealt with a cone. And so basically here, I don't know if you were given a picture or not. I mean, they might have given you a picture of the problem. Again, I haven't seen, what it looks like, but basically A was at the top, like B is somewhere here on the circle. So like from A to B, essentially, this is the slant height, usually designated with L. And then they wanted to find the volume of the cone rounded to the nearest whole number. Okay, so essentially the slant height here was 85. The height was given as 77. And then what you do is just Pythagorean theorem, because the height, radius, and slant height make a right triangle. So it's basically r squared plus 77 squared equals 85 squared. So we can go to Desmos, figure out the radius. Okay, so the radius is 36, and then we need to plug that and the height into the volume formula for a cone. Volume for a cone is 1/3 pi r squared h. If you don't have that memorized, it is on the reference sheet, but it's still something good to have memorized. So we're going to do 1/3. Now the pi actually doesn't matter because the k here that they want is the number, the coefficient of the pi, or the number multiplied by pi. So we can actually essentially just ignore that, and I'm just going to type the rest of this in to Desmos. 1/3 r squared times 77, 33264. So that is the number that's technically multiplied by the pi to get the volume. So the correct answer for this one is just letter A. Okay, next up, this is one I had seen or heard about before, but had not had enough information to actually set this, to figure out what it was asking for, how to solve it. But fortunately, there were a couple people that provided, some more details about this. Basically, this is a problem where a person sells two types of tables, two different shapes, pick whatever shapes you want. You're given total revenue, you're given total cost, you're given the relationship between like the revenue and cost for both types of tables. I want to know how much more profit did this person earn from selling one type of table than the other. Okay, so this is basically a system of equations you have to set up. First equation is a cost equation where the cost for x, which is, I'm going to use that for the hexagonal, and y for the circular, total cost was $36,000. Okay? Then we also know his revenue is $80,000. Now, how do you get the revenue? Well, the revenue for selling a hexagonal is 2.5 times its cost. So that means it's 2.5 times x. And the revenue for selling a circular is 2 times its cost, so 2 times y. So we take this system of equations and we solve it for x and y. Now, because the numbers are quite large, I'm just going to solve this using regression rather than graphing it out. All right, so there are values. X equals 16,000, Y equals 20,000. So now we have to, that's how many he built to basically to get these values, you know, for total cost and for total revenue. Now we have to figure out the profit, but specifically how much more profit did he earn from selling hexagonal than from selling circular. Okay, so this is where it gets a little confusing. So the profit for hexagonal is the total cost for selling hexagonal, total revenue from selling hexagonal minus the cost. Okay, so the total revenue was basically, let's see here, just my notes to make sure I do this correct. It's going to be just 2.5 times x right here. This is basically a revenue equation. But the point is now we know x, so we can just plug in the 16,000. And then we're going to subtract from that his total cost. Well, his total cost, that's just the x value itself, so that is 16,000. So if we go to Desmos, type this in, we should get 24,000 as the total profit from hexagonal tables. Basically, it's 2.5 times x1 minus x1. $24,000. Let's call this H. All right, next, same thing for circular tables. 2 times 20,000 that were sold minus the cost, which is 20,000. And by the way, I misspoke there. 20,000 is not the number sold. 20,000 is the cost, total cost of the tables. So when we do this, we should get, just give me my notes here, it should just be 20,000. Circular is going to be, again, 2 times 20,000 minus 20,000. Yep. So now what's the difference in profit? It's just H minus C. It is $4,000. All right. There's probably a quicker, faster way to solve this using the ratios of the various things, like the ratio of the revenue and the ratio of the cost and all that stuff. So if you have an idea, if you know how to solve this in a much quicker, faster, easier manner, I mean, feel free, go ahead, respond in the comments below, and I'll take a look at it. And basically, and post the method in a in an alternate solutions video at some point. All right, next up, basic percentage question. This could be talking about whatever different thing. Basically, something increased in by something percent after 1 year, and then it decreased by a certain percentage after another year. And the question's asking, what's the overall percentage increase, after the 2 years? So they want you to take the first year and just subtract the second year number from it. So in this case, 221% minus 21%, 200%. That's what they want you to do, but that is wrong. The reason is because the 21% increase is basically of the new value after the increase. The 21% increase is not, based on the original starting value. So the easiest way I find to do these is to just pick a number. So for example, my starting value is 100. Okay, it increased by 221%. So that means I take my starting value and then I take 221% of that and I add it to it. So my new value is 321. Then 321 is going to decrease by 21% of it. So now I get this. So this is my ending value. So I started at 100, I ended at 253.59. What is the percent increase? Well, if you look at the answer choices, basically it's really, the way you find percent increase or decrease is you subtract new minus old divided by old. So that would be the 253.59 minus 100 divided by 100. And then, of course, to convert it to a percentage, you just multiply by 100. 153.59. So which of these is closest to it? Well, it's obviously 154%. And that's your correct answer. Now, I would not, you can set up the equation and solve a generic equation for x for this. And so that's a perfectly valid approach. And I'm talking about technically it's like x plus 2.21x, and then that's 3.21x, and then you do minus, 0.21 times that, and you get, whatever x, and then you have to find the percent change between that and the between that and the x value and blah, blah, blah. But I think it's much easier to just use numerical values and specifically to start with 100 as your as your original value. Okay, let's move to the top of the next page. This question is another repeat question, but I wanted to mention it here because of a method that I did not mention in the original video, which is so much faster, quicker, and easier to solve this than the method I mentioned there. Okay, this first appeared June 2024. So again, if you had watched the official problem set video for the June 2024 exam, you would have been familiar with this question and known exactly how to solve it. All right, so basically what's going on here is, also one other thing I want to mention too, there are variations of this. You could have different x coordinates for the third point, the terminal point. You could have like -1. Some of them I saw had +1/2. It doesn't matter what the value of the x coordinate for the terminal point is. The approach is still the same. Okay, so you have f over here at 1, 0. You have g over here at 0, 0. And then somewhere there's a point over here, h. It's at -1, d. So h could be up here. H could be down here at -1, 0. Or h could technically also be down here. We don't know. All right. Here is the super fast, quick, easy way to solve this. This is a unit circle problem. Remember, on the unit circle, you have, every single point has an x-coordinate and a y-coordinate. The x-coordinate is equal to the cosine of the angle. The y-coordinate is equal to the sine of the angle. So all you have to do is you go through each answer choice and you take the cosine of it, and one of them will give -1. The answer choice that does is the answer, and that's it. And that's how you can solve this problem in 30 seconds. So first, just make sure these are radian values, so make sure we're in radians. Okay, we are. Cosine of 55 pi, -1. So what does that tell us? Well, that's the answer on an official test. You wouldn't need to do anything else, but I'll just show you that the others do not match. Wait, that's over 2. Sorry, this is over 2. Okay, so notice A gives me -1. This one gives me +1. Wrong. This one gives me 0. Doesn't match. This one gives me 0.202, whatever. Oh, I forgot the pi. That's why it's not a common value. This one gives me 0 also. Okay, so the point is, correct answer is A. That's how you figure it out. You don't need to do any other work. Now, I'll just mention briefly the approach I talked about originally back in the June video, which took a while to explain. I'll briefly explain it now. Essentially what's going on here is angles that end on the positive x-axis, that have a terminal point on the positive x-axis, those angles are always going to be like an even number of pi. 0 pi, 2 pi, 4 pi, 6 pi, 8 pi, so on. And then over here on the negative x-axis, they're going to be an odd number of pi. 1 pi, 3 pi, 5 pi, 7 pi, 9 pi, 11 pi, so on and so forth. All right. Then for the y-axis, technically up here you have, it's like even plus 0.5 pi. So that means like 0 plus 0.5 pi, which is just pi over 2 or half a pi. And then it's going to be 2.5 pi, which is really 5 over halves pi, and then 4.5, and then 6.5, and so on. And down here, it's just going to be odd plus 0.5 pi. So basically, once you determine, like with this -1 thing, because notice each of these angles that they give you, it's either a whole number of pi or it's divided by 2. There's nothing that's like in the middle of the quadrants, right? So once you determine that, okay, if it's -1 something, it's going to have to be an odd number of pi over here. All right, well, it has to be a. Okay, so for this specific example, this is an alternate way you could think about it. Now, if you had a different point, say your point was like 1/2 comma d, so it is up here technically in the first quadrant somewhere. I mean, then you could not do that. Then because then the angle is not on one of the axes, so you can't use this trick. Then instead, it's basically just do the cosine of the angle, figure out which one gives you 1/2 as your answer, and that's it. All right, let's talk about the next problem. So I covered one like this previously, except I didn't have really the full question, and so the previous example of this question was probably like not great, didn't really match what the problem was asking for. However, again, more people posted about this, got more information about it. It's an exponential function. Your base is a fraction, and it wants to know what the value of this represents. So I'll just tell you, the correct answer for this one is going to be A. So essentially what's going on here is, or the way to think about this. All right, initially at the beginning, say when t is 0, right, you have 64 reindeer. Then if you plug in t equals 1 and you go ahead and whatever, work this out, it basically goes, okay, to 80 reindeer. So for every 4 reindeer in the current year, the population will increase by 5, I guess I should say reindeer, in the next year. So essentially what it's saying is that the ratio, like essentially the rate of increase is going to be 1.25, 1.25 greater. So in other words, for every 4 reindeer in this initial year, you have 64, right? If you divide that by 4, that means there's like 16, there's like a 16 multiplier, okay, for the number of reindeer. Just because 64 total, and so how many groups of 4 could you make? Well, 16. In the next year, there are then going to be 5 times that, which is 80. Okay? Now, if you continue the pattern going forward, take 8, say now there's 80 in the current year. Okay? So you divide that by 4, again you have 20. So you have 20 times multiplier. Then you multiply that by 5 and you go to the next year and it's going to be 100. And so now if I go to Desmos, I can just plug some of these numbers in, just to confirm essentially what's happening. So it's like if I type the function here, okay, now, whoops, let me make a, let's just make a table here, and let's just start it at 0, 1, 2, 3, 4. Okay. So notice this basically confirms what's happening, right? 0, it's at 64. Next year, it goes to 80. Next year, it goes to 100. And then if you follow the pattern, okay, 100. For every 4 reindeer, which means it would now be like a 25 times, whatever, like multiplier, there's going to be 5 in the next year. So take this, multiply it by 5, you get 125. Okay? And notice right here, year 3, 125. So that's basically what it's asking. The correct answer is A. I mean, B and D are out automatically because they have the things like the numbers switched. They have the 5 for the current or previous year and then 4 in the next year, and it's the opposite. Like the 5 that's on top is going to mean like whatever 5 in the next year for 4 in the current year. So basically, it has to be A or C regardless right off the bat. But the problem with C is like basically going, back 1 year and then looking ahead 1 year. So it's kind of like, you know, you're comparing like the f of 0 value to the f of 2 value, or the f of 1 value. That's like like say that f of we're in year 1. F of 0 is the previous year. F of 2 is the next year. So you're comparing these two, and that's not what's happening. It'd be comparing like here to here. Dividing this by 4 is 16, and then multiplying by 5, you don't get 100 when you do that. So that's basically why C is out, and the wording in that is incorrect. For this next problem, number 12, I went back and forth on the setup of it and basically how to exactly to word the answer choices. And this is what I, basically like decided on. So here you have a cubic polynomial with some constants. You're given 2 points that it goes through. One of them is an x-intercept or root. The other one is a y-intercept. And you're also told about basically another, x-intercept. That's what the S stands for. Another 0, a root, so on. It wants to know, could this value for S be positive 4 or negative 4? Could it be only one of them? Could it be either of them? Or could it be neither of them? All right, so the way I set this up is to specify that the constants in this problem are all integers, meaning there's no fractions of any kind. Don't know exactly what it said on an official test question, but this is just how I set it up to work it out. So, okay, basically what's going on here is, first of all, if we plug in 0 for x, essentially you've got something that looks like this, and that's equal to 38. So this stuff all just cancels out. Okay, that tells us D is 38, right? So right off the bat, we know that. Therefore, what we can do is the following. Not that yet. Okay. So if we take this cubic polynomial and we basically factor it, right? We have one x-intercept at -9. That means the factor is going to be x minus -9, or in other words, x plus 9. Okay? Then you also have the a value out here, which I'm just going to say factor out front. And then here you have your other two x-intercepts. Okay? I'm just going to call them like S1 and S2 for right now, just to differentiate them from just S. So the point is, could you put 4 in for one of these, or could you put -4 in? So, okay, if I put in 4, all right, here's what I think you're looking at, or here's basically the way kind of to reason your way through this to solve it. So if you go ahead and you multiply all this out, basically you use FOIL on the first two parentheses, and then you take that trinomial, which is going to be what, x squared plus 5x minus 36, and then you multiply it by this other binomial here, the x minus the third x-intercept. You multiply this all out, okay? Eventually, like this times this and then times this, that's going to be basically your number term or your constant term. However, it also will be multiplied by the a out here. Okay, so essentially a times 9 times -4, and then times whatever this other, it's not s over 2, it's s2, this other third x-intercept is, okay, that makes the number term, which has to equal 38. All right, so if I just go into Desmos and just take a look at this, I'll just call it S in here for right now, and I use regression, okay, and I set this next to 38. Notice it's giving me a non-integer value for a, okay? It's giving me an integer for the other thing, for the other root, but not for a. Okay, so now let's say I specify, all right, a has to equal 1. Just see, maybe I can slide this over and just move it to the side just so we can see more of this. All right. And so if I set step to 1, if I go ahead and just move this, notice it doesn't matter what I set a equal to, what integer value, whatever, and go up to 20 here. Notice the other x-intercept value is not going to be an integer. It's always going to be a decimal. The reason that matters, or the reason that is important, is because basically that means, so this right here is a non-integer, i.e. this is a decimal. So this parenthesis up here is going to be x minus some decimal. The reason that matters, the reason that's important is because then if you go ahead and you multiply this whole thing out, okay, even if you would be able to make 38 as your whole number for D, as an integer. That would be fine. A would be an integer. That would be fine. The problem or the issue is that B and C are not going to be integers. You know what I'm saying? In other words, just say A is 1, so whatever, we'll ignore that, right? And then you have the x squared plus this thing becomes 5x minus 36, okay? And then over here, you've got x minus, and I'll just jump back to Desmos. So like when we said a equal to 1, okay, the other thing is that number. What is it here? It's negative 19 over 18. So that means, if we're going to set this up, negative 19 over 18. Basically, it would essentially look like this. So, negative 19 over 18. The point is, now if you went ahead and multiplied this out, right, you're going to get a bunch of, so this would actually be fine. This part is what actually, turns into the 38. But it's the other multiplications. It's this times this. It's this times this, which are not going to give you integer coefficients on, for example, here the x squared term, negative 19/18 x squared, and then here with the x term, 5 times 19, 95, negative 95 over 18x. And when you combine them with the other x and x squared terms that you get by doing this multiplication, the other ones aren't going to have fractions in them, so the end result is that b and c are not going to be integers. They are going to be fractions or decimals, whatever you want to refer to them. So in this one, I chose basically, this one I chose 4 because it's x minus 4. I said s is positive 4. If I chose negative 4, technically this would be plus, and now this would be plus, and all that's going to happen is it's going to change essentially the sign. The actual numerical value doesn't, it doesn't matter, it's irrelevant. Okay? So now it would be like, this would be plus 19 over 18. This would be plus 19 over 18. But nothing else changes. You're still getting fractional or non-integer coefficients for the b and the c terms. So the way that I read this problem, the way that I've set up this problem, my answer for this one would be D. Now, maybe the problem is like worded slightly differently or set up differently, or maybe it doesn't specify that they're integers, in which case it probably would be able to be either of them because you can use whatever fractions you need to, to make everything work out. But the way that I set up this problem, the way that I worked it out, I believe the answer to this one should be letter D. It cannot be either of those values. Okay, moving on to the top of the next page. So the last problem here, number 13. This is basically really just an exponential, basic exponential function type problem. So essentially, you're saying that you have something at the surface, say like whatever, light intensity is 100. Okay, and then when you go down 10 inches, it's now 69% of that. So 69% of 100, it means it would just be 69. Then you go down another 10 more inches, so now total depth 20 inches. And it is 69% of the light intensity at 10 inches, meaning it is 69% of 69. and then it wants to know, okay, so down here at 20, this is what percent of the light intensity at the um, surface of the water. All right, so basically all you're doing here is just really calculating, 69% of 69, which is 47.61, and that's it. Because if I started out with 100 as my original value, basically you find 69% of that twice, and you end up with this number. And this number is your answer, so it's just 47.61%. You just type it in 47.61, and that's it. All right, so I hope you enjoyed these questions from the March 2026 SAT math section. Again, worksheet video number 1. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. Also, make sure to check out video number 2, worksheet number 2, and then also video number 3, the repeat problems, basically the ones that have been featured previously, some of them multiple times, in past videos and past worksheets. Additionally, if you have questions or comments or alternate solution methods, please feel free to leave them down below, and I'll respond to them and possibly include them in an alternate solutions video coming up in the future. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are 2 versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.